Okay, today we start a new unit. All right, this unit is on. It's called exponents, but we're dealing with polynomials and exponents and exponential equations. All right, but first we're going to start off with looking at the rules for exponents. And the first thing we're looking at is a power rule. A product rule. And we'll get in that in just a minute. But let's do some definitions a little bit. Monomials. A monomial is a number, a variable, or a product of a number and variable. Okay, so 3 is a monomial. X is a monomial. 3 times x is a monomial. Okay, you don't see any plus, minus, you don't see any pluses or minuses, even x squared, because that's multiplying a variable. So 3x squared, 3 times x times x, negative 3/4 x, y, that's a monomial. It's a number, it's an integer. It's a rational number being multiplied with the variable x and the variable y. You could even say y squared, all of that is being multiplied. There's no plus or minuses in it, okay? Monomials with the same variable and exponents are called like terms. All right, so if I've got 3x and 4x, they have the same variable and they have the same exponent. This is understood exponent to the first power. 3x squared is not the same as 3x. They don't have the same exponent. But 4x squared is a like term with 3x squared. It's got the same variable and exponent. Okay? All right, to add and subtract monomials, all you're going to do is combine like terms. So all you're doing is adding or subtracting the ones that have the same variable and exponent. Okay, so all you do is add and subtract their coefficients. All right, you do not change the variables and exponents. All right, we're adding and subtracting. So 17x and 25x, we're subtracting. They have the same variable, same exponent. So you look at the coefficients. 17 minus 25 is negative 8, and put down your variable. Okay? Look at number 2. They both have the same variable and exponent, right? So that means I can add them together. Negative 23 and 6 is negative 17. Put down your variable and exponent. All right? 3 cubed BC, 3 cubed BC. Again, they have the same variables and exponent. So you add together your coefficients. Negative 15 plus 6 is negative 9 a cubed BC. All right. Let's look. Let's go down to this one. All right, look at number 9. All right, this you got to look to see your variables. All right, my y's, and y'all keep them in alphabetical order. So I'm doing my y's first. I've got 2 y's to the first power. So I'm going to add their coefficients. 3 plus 4 is 7y. And then I'm going to look at my z's. And y'all remember, the sign in front of your coefficient goes with it. So 9 plus negative 3 is positive 6z. Okay? Especially when you get a longer one, it's got a bunch of different variables in there. I like to put boxes around each monomial, each term, and then combine them. That way I can make sure I'm not missing one or putting one twice or combining it with the wrong term. All right, so I'm going to put boxes around the ones with B. So 12 minus 10 is 2B. So those are done. And then I've got this 8A left over.
Y'all, tell Mr. Fields we might send our drug.
Sorry about that, y'all.
Got him right here, Dr. V.
All right, and I would just put this with my variables in alphabetical order, okay? ABC order. All right, let's look at this one. M squared n, that one doesn't do, m squared n, and that's like a -1 there, okay? So we're going to combine those like terms. They have the same variable and exponents. So 10 plus -1 is 9 m squared n, and then plus 7 m n squared. Okay? All right. And let's look at number 11. Let's look at the ones that are alike. I got a w square, and then I've got another w square. All right, and then I have a w and a w. So they have the same variable but different exponents. And in this case, you're going to put your highest exponent first. 13 plus 4 is 17w squared. So those are gone. And then I have just w's. So 9 plus -31 is going to be negative 22. Yeah, 22w. All right. Number 13 says find the sum of 16y squared and -5y squared. Remember, when you have sum of, difference of, where the and sign is where you're going to put your operator. So this is this monomial plus this one. So they have the same variable and exponent. So 16 plus -5 is 11y squared. And then it says subtract 9a from. This is kind of like one of those turnarounds. I'm subtracting this from this, so it's minus 9a. Have the same variable and exponent, so negative 15 minus 9 is negative 24a. Okay. Let's look at. All right, this one says the difference of. So where the and is where I'm going to put my subtraction sign. Okay. X squared y, they have the same variable exponent. So 10 minus 2 is 8x squared y. And then, And then we've got, this one says from this, subtract this. Okay, same variable, same exponent, so they're like terms. So it says from this, subtract this. Okay, so -9 minus -2 is -7 CD squared. Remember, minus a negative is like a big plus sign. Okay. All right. Let's look on the other page. All right, it says to multiply monomials. Well, before we were adding and subtracting, but to multiply monomials, we're going to use the product rule. Okay, and the product rule applies to our exponents. Okay, so if I have XA times X to the B, that's going to be A plus B. So in other words, you're adding your exponents. Let me prove how this works, because a lot of times when I was learning this, I had to prove it to myself to remember which one I do. Do I add or multiply? So if I've got x squared, come on, my pen, x, sorry, my pen went out. Okay, if I got x squared, and I'm going to multiply it by x cubed, all right, how do I write x squared in expanded form? So what does x squared mean? It means x times x, right? All right, how do I write x cubed in expanded form? It means x times x times x, right? And we're multiplying these two. So now, how many x's do I have? 1, 2, 3, 4, 5. So my exponential answer would be, our exponent form would be x to the 5th. If I'm writing it as a power. You know, remember this whole thing's called a power. This is, x is your base, and 5 is your exponent. 5 tells to multiply x 5 times. All right, 1, 2, 3, 4, 5. Here we were multiplying it 3 times, and here we were multiplying it 2 times, right? So if we multiply them all together, we're multiplying it 5 times. So that's why the rule is to add your exponents when you're multiplying. And they have to have same base. Kind of like terms, all right? Like terms when you're adding and subtracting, same base when you're multiplying. Okay? So x squared times x cubed is going to be x to the 5th. And a to the 9th times a. And it's understood that's an invisible 1. Okay? So a to the 9th, 9 plus 1 is a to the 10th. Now I'm going to tell you, this invisible 1 will get you every time, most people. In fact, I can remember getting so frustrated because I'd do the work and I'd turn it in and I'd fail it because of those invisible 1s. I would forget to add that 1, and I would have given the answer a to the 9th. Okay? And it's so the way I cured it was anytime I got a paper and I saw just the variable with no exponent, I'd put a 1 there. I'd write that invisible 1 down until I got the habit of remembering that there's to the 1 power. Okay? So when you see it, you might write it down if you see yourself doing that same thing. Okay, W is the base, so it's being multiplied here, so I can add my exponents. So it's going to equal W to the 7 plus 4, or W to the 11th power. Okay. All right. Now, when you have coefficients, you multiply the coefficients and you simplify the variables with the product rule, meaning add your exponents. Okay? The exponents are only going with the base here. All right? If I have 4x squared, that means 4 times x times x. If I have 4x squared, that means 4x times 4x. All right? So unless the square's outside of parentheses, it's only going with what's right there underneath it, the x. The 4 is not being squared. Okay? So all I'm doing, I'll tell you what, let's do this one in expanded form. So you can see. Okay, if I was to write this in expanded form, it would be 4 times x times x. All right, and we're multiplying the 3x to the 5th. 3 times x times x times x times x times x to the 5th, so there's 5 x's. So now all of this is being multiplied. So my x's, 1, 2, 3, 4, 5, 6, 7. So I have x to the 7th power, and then 4 times 3 is 12. Okay? So I wanted you to see that, understanding why you're multiplying the coefficients. Okay? They have nothing to do with the exponents. So we're just multiplying the coefficients. Okay? All right, so this one, multiply your coefficients, be 15, and then same base, right? So we're going to add our exponents. So 6 plus 2. So it's 15 to the x to the 8th. Okay? In your notes, I would write it like that so you can see what you're doing. All right, it's 3 times 5, and x to the 6 plus 2 equals 15x to the 8th. Okay? All right. Let's get over here with the... All right, so multiply your coefficients. So negative 4 times 3 is negative 12. All right, and now remember, we only do same base. So a cubed times a squared is a to the 5th. And then b, don't forget that invisible 1, b to the 1st power times b to the 5th. So it's going to be b to the 6th. Okay, so that's going to be your answer. Don't forget that invisible 1. Okay. All right. We got 3 coefficients here. So 2 times negative 5 times 3. 2 times negative 5 is negative 10 times 3 would be negative 30. And then y. It's y to the 1st power. Base is the same, y's. So all I do is add my exponents. 1 plus 2 is 3, plus 3 is 6. Okay. All right. Coefficients, 6 times 7 is 42. And then m and m. So visible 1, so it'd be m cubed, and then n and n, invisible 1, would be n to the 5th. Okay. Let's see. Let's look over here at this little darling. Okay, you say, well, what about him? Well, he's being multiplied with this and this. So again, multiply coefficients, all right? Multiply the big numbers. -4 times -5 is positive 20. And then r times r to the 4th. It's r to the 5th, invisible 1. And then S2, the S1 will be S3. Okay? All right, and let's do one down here with some fractions. And y'all, fractions, a number just like anything else. All right, 1/4 times 8 is the same thing as 8/4, which is 2, times -6 is -12. Okay. And then m's, we got 3 of them, and then n, we have 3. Don't forget those visible ones. All right, let's look down here at 35. Okay, so they're right next to each other, so that means they're multiplying, and then they're adding. So remember, order of operations, we multiply before we add. So let's multiply these first. 2 times 4 is 8, and my x's, see, I'm going to go ahead and write these invisible ones so I won't forget them. So my x's, 5 plus 1 is 6. My y's is going to be 2 plus 3 is 5. And then we're going to bring down the add sign. And then 3. And then my x's, 4 plus 2 is 6. And my y's, 4 plus 1 is 5. Now, do these have the same? Remember, when we're adding and subtracting, we have to have like terms, right? Are these like terms? Well, yes, they are. So now just add your coefficients. 8 plus 3 is 11. X to the 6, 5. Okay. Oh, let's see. Let's try this one. All right, so we multiply first before adding and subtracting. So let's just bring this down. And then 12 times 12. 4 times 3 is 12. And then the m's, 5 plus 3 is 8. Put that invisible 1. And the n's, 1 plus 7 is 8. Now we're adding or subtracting, so we're subtracting. We can only add or subtract like terms. Same variable, same exponent. So they do have the same variable, same exponent. So this would be 19 minus 12 is 7. Okay. All right. Let me just, if I have, let's say, if I had 2x squared times 4y plus 3x squared times 2y squared. All right, so do your multiplication first. So it'd be 8, and the x, that's the only one I have, and the y is the only one I have. Bring down your plus sign. So 3 times 2 is 6. X squared is the only one I have, and y squared is the only one I have. Okay? Now, we're adding. Remember, only add like terms. Are these alike? Well, this y has an exponent of 1. This has an exponent of 2. So I cannot add them. Okay? This would be your answer. Because I cannot combine those. That's as far as I can go. Okay? Alright. These are not like terms. So, cannot go any further. And this is a separate thing, okay? Alright. Okay, tomorrow in class we'll go over this some more and then do some practice work on it. Alright, y'all have a good evening.